All right, let's talk about the inverse of a 2 by 2 matrix. So generally, when trying to find the inverse of a matrix, the inverse of any matrix is always given as the adjoint of that matrix over the determinant of the same matrix. So the formula for the inverse of a matrix is always going to be adjoint over determinant. So looking at what we have right here, we can shorten many of these things to using their symbols. The symbol for inverse is often written as a raised to power minus 1. And we can write adjoint in short for this. Then we can write our determinant this way. So this is another way we could have written the formula. The inverse of A is always going to be the adjoint of A over the determinant. Let's try and solve some few questions. All right, we're given this question, A equals to 2 minus 731, and we're told to find the inverse of matrix A. Don't forget, our inverse is always written as the adjoint of A over the determinant of A. So this implies that we have to first find the adjoint of A and then the determinant of A. Then we can easily find our inverse. So how do we find the adjoint of matrix A? The adjoint of matrix A is when we interchange the leading diagonal. This is the leading diagonal. That means we have 1, 2, and we change the signs of the other diagonal. We have minus 3, and then we'll be having 7. So this is the adjoint of A, quite simple. Then we go on to find the determinant of A. How do we find the determinant of A? When you find the determinant of A, when you multiply the leading diagonal and subtract the other diagonal from that. So what we have is, we'll be having 2 times 1, that would be 2, minus 3 times minus 7, that will be minus 21. This will be 2 plus 21. This will be 23. So we've been able to get our adjoint and our determinant. So what we need to do next is to apply the formula for the inverse as the adjoint over the determinant. So the inverse of A will be equals to the adjoint over the determinant. All right, so this is a situation where we have scalar division, which I've explained in a previous video. So what you have to do here is to divide every element of this matrix with this scalar 23. So what you'll be having is 1 over 23, 7 over 23, minus 3 over 23, and 2 over 23. So you go on to check for if there are any, if you can simplify any of this fraction, then you go on to simplify it. But looking at what we have here, this has to be our final answer. So this therefore gives me the value for the inverse of matrix A. All right, you can pause this video right here and attempt this question. So let's try and find the inverse of this 2 by 2 matrix. Now don't forget the formula for our inverse as the adjoint of A over the determinant of A. So we need to go on to find the adjoint of this matrix A and then the determinant. So the adjoint of A is gotten by interchanging the elements of the leading diagonal. So we have minus 5, 4, and changing the signs of the other diagonal, minus 2, minus 3. And the determinant is gotten by multiplying the leading diagonal. So we have, this is 4 times minus 5, that will be minus 20, minus 3 times 2, 6. So we have that as minus 26. So we've been able to get both our adjoint and determinant of matrix A. So we can go on to apply our formula for inverse as adjoint over determinant. So we'll go on to have our scalar division. That will be minus 5 over minus 26, minus 2 over minus 26, minus 3 over minus 26, and 4 over minus 26. We can go on to simplify some of these values. Of course, we will be left with 5 over 26. Then here we'll be left with 1 over 13. We'll be left with 3 over 26. And we'll be left with 2 over minus 2 over 13. So this gives us the value for the inverse of A. So I really hope this video was very helpful. Alright, so I would love you to make an attempt to this question and let me know your results in the comment section. You're supposed to find the inverse of this 2 by 2 matrix. Alright guys, thank you for joining. I hope to see you in the next video. Bye-bye.